Okay, so let's take a look at this question, another gear system. Before we solve anything over here, we have to understand the orientation of the gears of A, B, C, and D. If I would like to draft the system over here, then I will say that A and B, they are like the touching. So this is B and that will be A. So basically they are touching. So if they are touching contact, then we have to use the velocity ratio to solve the things. And I will say that my omega A times RA, that will be equal to my omega B times RB. So we all know this. So next, that will be on the C, the gear. That will be the womb gear. And basically C, they is having the same shaft with B. Okay, so then if they are on the same shaft, so whatever B in the angular velocity or even the angular acceleration, C will have the same value as well. Okay, so that will be something that we would like to talk about here. Okay, and we know that the gear C, basically it is get contact with D. So that at the end that we have our D. So that will be D. And because of the contact, again we will apply the velocity of ratio. So then we will have that again. So that will be the orientation of the gear system in our situation right now. When we understand the whole orientation of the gear system here, now we will take a look at the question. What the question is telling us over here. So there is saying the gear A with angular acceleration given us a function towards time over here. And then what the question asks us to look for is to look for the angular velocity of gear D. So that will be from A, transmit the power to the final gear D when t equals to 5 seconds. So which means that if we started the time from the first second, the second, the third, the fourth until fifth, what is the angular velocity? And we know that that will be ever changing when the time is increasing, because we know that the acceleration of A, which is the prime power, it is changing against time. So when the time is increasing or decreasing, the angular acceleration will be different. So that's why it is not constant, as we all know. So the condition is starting from rest. So gear A also at rest. So which means gear A and gear D, that they are at angular velocity 0. Initial condition. So initial. So they are 0 radius per second. Okay. So that is what we are having, the condition. So I put it there. And then what is next? That will be all the respective radius of the gear. That will be denoted as our RA, RB, RC, and RD. So now, first thing first, if you look back to our diagram that we have draft. So at A, we are having a function. So that will be the T 1 over half. Oops. That will be the T 1 over half. Basically that is the square root of it. And we would like to do an integration for this function so that we can have the angular velocity. So I will get a new space over here. So starting from this equation, we can write the thing as, we know that angular velocity, that will be divided by time. We will have our angular acceleration, and that will be the delta for it. So if right now we are moving our t over here, so then we can start our integration in such manner, and we know that that will be each having the initial condition and as well as the ending condition, and that will be our initial time and the ending time. So I will take away the space over here. So as we all know from the initial condition, starting from rest, that it is 0, so this definitely it is become 0. So then I can put that as 0. And of course omega A1 we don't know. And the time, initial condition 0, and then at 5. So that will be actually what we can put in. So I'm putting there, and I'm putting 0 over there. So omega alpha A, that will be this function. So what we need to do over here definitely is move the whole function towards that place, and I will rewrite that and become bigger. So basically that will be the mathematics that we can perform. And if we make a normal mathematical operation, definitely that is what we will have. That will be 0 ending of it. So to integrate towards t of this, that will be something we can obtain. Plus 1 divided okay, so don't forget to put our value over here. So simple calculation that we will have will be 3/2, and of course that will be the same, 3/2. And the 3/2 over here, then we can work with our 30, and basically that what we will have. So I will just erase everything, because 30 divided by 3/2, we will get 20. So you can use a calculator to do that basic mathematics calculation. So that will be what I will continue to move it here, and the whole equation basically is solved. So things become now more simple over here. That definitely we will just have back our omega A1. And right on my right hand side, so if I do a simple calculation by putting 5 minus the function of the 0, then I will get the value of 223.61 radians per second. So on the first stage, we solve omega A when this A1, basically I can say it is when t equals to 5 seconds. Then I will have such value. And of course, if the question is modified, the time may not be 5 seconds, that can be any time 1, 2, or 3. All you need to do is to replace that into the t, and then you will get another different answer, but that just represented different time, or when the time is increasing, our omega A, which is angular velocity, is changing as well. Okay, so now we solve omega A when the time is 5 seconds. And it will be about time for us to solve the second part of the question, which is we need to determine the omega d, which is the angular velocity of gear D. Okay, so which is here, if we want to take a look at that. So omega d. So when omega A, we successfully obtain the value. Now we can make use of the whole velocity ratio that help us to do it step by step. And this will become very simple because the question has given us gear A, gear B, C and D, the radius respectively. So what we need to do right now will be very simple. So from here, we know that that will be 223.61. That's our calculation. And RF from the question, that will be 25. And then omega B, we definitely don't know, but RB, yes, we know that RB will be 100. That will be all from the question. So by doing so, we can get our omega B very easy. That will be 55.9. So I will move a bit. And then there will be radian per second. So, second step, once we got our omega B, so insert into there, and then we'll be telling us that omega C actually is also 55.9 radians per second, or radian per second. So if we know that omega C, then this will be easy for us. And RC, from the question, we know that it is 40. And RD, it is 100. That means omega D will be 22.4 radian per second. And we solve it. Everything from the question. Then we draft out the graph or the diagram. Then we establish the gear law, velocity ratio. Then from the function we do integration. We got our omega A. Then that helps us to get omega B, then C, and after that D. So that will be the answer for it.